Alright, this is sample problem 5D from page 179 in your Holt Modern Physics book. And we're told that we have a stuntman who is attached to a bungee cord with an unstretched length of 15 meters, and he's jumping off a bridge which is 50 meters above a river, and the maximum stretched length of the bungee cord is 44 meters. We're given a spring constant for the bungee cord of 71.8 newtons per meter, and what we want to know is the total potential energy relative to the water when the man stops falling. So in other words, when he gets to this stretched out length of the bungee cord. A couple things we need to remember. The total potential energy is equal to the gravitational potential energy and the elastic potential energy here. And we have a simple formula for each of these. We'll start with potential energy due to gravity. So PEG is equal to mgh, and if we plug in the numbers for our stunt man, we get this. We start with this, and remember, since we're talking about energy, we can go ahead and disregard the sign on acceleration due to gravity. The question is about this height. What height will the stuntman be at when he stops falling? Remember that we're looking relative to the water, so we're going to use the height above the water's surface, or 6.0 meters for h. We get a potential energy due to gravity of 4,120.2 joules. We're going to set that answer aside for right now as we go on to figure out the potential energy elastic. So remember that our equation for potential energy elastic is 1/2 kx squared. And k is our spring constant. We were given that. X, what is x? Well, x is the difference in length between a deformed and undeformed elastic material. So what we're looking for is the distance between the unstretched and stretched length of the spring. So x is equal to 44 meters minus 15 meters, or we get an x of 29.0 meters. Now let's plug that in. We get an equation that looks like this. Elastic potential energy equals 1/2 71.8 newtons per meter times 29 meters squared. So let's do the math. We get a total elastic potential energy of 30,191.9 joules. So now we want to find our total potential energy. So since our total potential energy is the sum of our elastic and our gravitational, we get a raw answer for our PE total of 34,312.1 joules. When we sig fig it, or 34,300 joules, or 3.43 times 10 to the 4th joules. Now, take issue with the fact that it seems an awful lot like those forms of potential energy should be in conflict with one another, since one is the potential to travel downward and the other is the potential to travel upward. Yeah, me too. However, your book handles it as total magnitude of potential energy, so we'll leave it where they do. That's it. Have fun. You're assigned page 180, problems 1 through 3, and I'll see you soon.